Hi, I'm going to do binomial hypothesis testing for two-tailed test and using the distribution menu. Okay, let's look at this question. The manufacturers of a brand of chocolates claim that on average 30% of their chocolates have hard centres. Okay, so we're interested in ones that have hard centres. That's going to be a success. In a random sample of 8 chocolates from this manufacturer, 5 had hard centres. So there's some data. Test at the 5% significance level whether there's evidence that the population proportion of chocolates with a hard centres is not 30%. So we're interested in whether it's not 30%, stating your hypotheses and show any relevant probabilities. Okay, so we begin with using the writing down the hypotheses. So we want a null hypothesis, which is the status quo, which is just that the proportion with hard centres is 30%, which is what the manufacturer said. Okay? And against that, we're going to see if there's evidence that it's not 30%. So our alternative is going to be not equal to. Okay, it's not a greater than, it's not a less than, it's both. It's a bit of both. It's just got to be either extremely large or extremely small instead of 30%. Okay, right. We then need to define what we mean by this P that we're testing. So the P is copied from the question, the proportion of chocolates with hard centres, the population proportion. We need some data. So we've gathered 5 hard-centred chocolates from 8. Okay. So X is going to be the number of chocolates with hard centres out of 8 chocolates. And that will have a nice binomial distribution, success being having a hard centre. Okay. And the number of trials is 8 because there's 8 chocolates. And the chance of success, we're assuming the null hypothesis is true, so that's 0.3. So we want to find out how unusual is our 5 hard centres out of the 8. So what's the probability of getting something at least as extreme as 5 hard centres? Okay. Now, usually we'd be finding a probability and we'd be thinking about copying the alternative hypothesis direction and adding an equals. But here we haven't got a direction, it goes both directions, so we just have to guess. So I'm going to guess that 5 is an unusually large number. So I'm going to say, what's the chance of getting something greater than or equal to 5? Okay. Now, if I'm wrong and it should be less than or equal to, I'll get a probability that's more than a half. So if I get a probability that's more than a half, I just switch it round and start again. Okay. Right. So let's just have a think of what we're going to be finding out. So I'm going to do a little sketch. So here we go, here's some kind of binomial distribution, okay, and say my number is 5 is about there, and I want to find this probability here, and then decide if that's very extreme or not. So, on the calculator, right, I want to be in my binomial, distribution menu, binomial. I want to do greater than tail. I have observed 5 hard chocolates. My number of trials is 8 and my chance of success is 0.3. And then let's have a look at this probability. So the chance of getting something at least as big as 5 is 0.0579. I'm going to press options in F1 to check if it's truncated, because when it truncates, it's not rounding, it's just truncating. Yeah, so when I report this probability, I need to round. So that's going to be 0.0580. Okay. I want to compare that with my significance level. Now, for a one-tailed test, we just stick with the 5% there. But for a two-tailed test, we have to split our 5% significance between 2.5% on one side, and 2.5% on the other side, okay, because it's a two-tailed test, because we're interested in things being different from 0.3, okay, not specifically either greater than or less than. Right, so I'm going to write down 0.025 to compare my greater than or equal to with just the right-hand tail. And we can see clearly that the probability of getting greater than or equal to 5 is much greater than 0.025. So that means, again, that 5 is not very unusual. It's not an unusual observation, so it seems reasonable to stick with the null hypothesis, assuming it's true because it fits in well with the data. Okay, so that means we have insufficient evidence to reject. Okay, we're testing at 5%, even though we've split into the 2.5%. Okay, so it is unlikely that the population proportion of chocolates is not 30% with hot centres. Okay, so that was copied from the question.